Hey folks, and welcome back for some more AI programming. So I'm gonna pick up basically where we left the work last time. I'm gonna do a little bit of live coding today because we only have to do just a little tiny bit more on the system before we can actually test out some simple actions. So the one missing piece, or at least probably the most central missing piece in our action scheduler, is the update method for the action scheduler. So let's add this in, and this is a very important piece because it will be essentially responsible for running and ticking these actions as we push them to the system. So we want something like this. Right, we have the action queues. So probably want what do we want to do actually? We want to, first of all, we want to check if the queue is empty, and that's a bit tricky currently. Let's see. So we have action queues. Each of them is essentially an array list of interfaces. So can we actually? I'm gonna do this. I'm gonna do this. Where were we? We're here. So I'm gonna very clearly declare here action queue is queue. And now that we have that declared and strongly typed, we should get better IntelliSense here. So I think we might just have to check the len to get whether or not this is empty or not. So if it is empty, then we basically want to skip the layer. So if len is 0, just continue. Continue with the next queue. However, if it is not empty, then at this point we should be able to get the current action. So this will be a pointer to means AI action interface. And what we need is essentially item 0. Like so. So that's the current action that is running. We can switch on the current action's state. Get state returns an action state, and the action state has a few different options for us here. So let's see. I think it works like this. I'm trying to remember the syntax for the switch cases in Zig. I think it works like this. Let's see if it does. Like so. Undeclared identifiers, we probably just need to like qualify these. So that would be like means dot AI dot, what is it, action dot waiting to start. Now that should be fine, shouldn't it? Let's try to build this. Oh no, it's because I still need this. Still need the action state to be there. Now we can even navigate to it, so that's fine. Okay, so if we are waiting to start, then we just do current action dot start. And maybe we should make this an optional. All right. I think we should make that an optional. Since we have it as an optional, we need to actually query it first. So let's do CA. CA is the captured value And that means that we should be using CA here for our poking at the action. I'm going to show you why I want it as an optional pointer in just a little bit. Okay, so that's waiting to start. We just started, that's it. Active, I don't think we need to necessarily do anything. But we're going to leave it there for now. The failed, succeeded, and interrupted, they should essentially all do the same thing. And that is, I'm going to copy here from the C++ version. The task has ended. Get rid of it and start the next one. So do ca.destroy. And now this is the place where we actually want to use the optional one. So we set the current task to null. Maybe actually before that, let's see. So we do Q. What is it? Is it remove? Ordered remove. Yep, ordered remove. We need it to be ordered, and I think that's an index, isn't it? That is an index. Yes, indeed. So I want to remove the first one, and right then, if the layer still isn't empty, so it's not null or 0. We want to reassign the current task, and again we just take the first one in the queue, so index 0. And this guy should now, by definition, be waiting to start, because it should not have actually started yet. So let's assert here that the current action, which we can just make sure that we actually have by using dot question mark, this get state should be means.ai.action state waiting to start, and then we can start it like so. So if we got rid of a previous one, then see if we have a next one, and then start that. So that's it. That's the switch case. Outside of the switch case, we can now check if current action is not null, and the current action actual object, which we can get out again with the question mark. If its state is means.ai.action, that's not how you do it in Zig. You use and means AI action state active. So if this is active, then we do current action update, and we pass in the delta time. And the C++ version at this point calls debug draw, which I guess can be kind of handy. We don't necessarily need to even have it there, but that's fine. Okay, remove the element at index I, shift element after index I forward, and return the removed element. Okay. Well, we can just ignore that. Okay. And what do we have here? Oh, so update actually returns action state here. This was something that I thought was a good idea in the C++ version. That's why I just brought it over, but evidently we don't use it for anything. So maybe we do at some point somewhere. So let's just do that. Let's ignore it for now. It will just return its current state. That's not a problem. Okay, so this should now be everything we need to actually pump the system, so to speak. We iterate over all the queues. We skip the queue if it is empty. Get the current action, check its state, start it if we need to, destroy it if we need to, start the next one if we need to. And yeah, so we could have updated and debug drawn the thing here in active, but we actually want to do it here after this switch case, because then we can just, with just this single piece of code here, we can update both the current active one, and also if we do this thing and we start a new one, we will update the new one here as well. Cool. I think this is all we need. And now we can turn our attention to the new component that will act as our it's kind of like the brain component, but not necessarily. So I can show you what I had in my previous incarnation of this system. So we have something called an actor component here. The actor component owns the scheduler. It also owns the actor context. And you can get them out of the system like this. This is a game object component in C++ in Basis. I think we might want to do something similar here. So let's do that. Let's add a component which has those two guys. In this we actually derive from the actor component, and we have a more specific one. We can't do anything like that in Zig, obviously. We're not deriving from anything anywhere, but this component actually doesn't really do anything. It has some commented out code here for something, and it just forwards all of its calls essentially to the actor component and updates the scheduler. So let's create an actor component which does essentially the same thing in Zig, and see where that takes us. right. So, I had to make a few small changes here, but let's go over what we have first of all. So I added a new component, actor component. It has just a normal context. It has an actor context, which is actually undefined here. The reason this is undefined is that essentially to initialize this guy, we need to resolve the pointers, as we can see here. Oh, actually, now that I think about it, probably doesn't need to be undefined. We can leave it like this, and I think we can use this syntax to actually leave it at its default values, right? Because we initialize everything here to null, null, and to null. So that's that. But yes, that's the actor context, the action scheduler. The actor context is essentially initialized by resolving the pointers, and to resolve the pointers we need the game object. And we can't get the game object here in the init function. Or maybe we actually could. Maybe we could get the game object from that context already there, but I don't typically do that. And even if we could, it wouldn't really work in this case, because as we talked about earlier, the result pointers will need to hook up the component pointers, essentially the siblings of this actor component. So if we have a vehicle controller component, then we want to hook it up here, right? And there's no guarantee that that will actually be the case here in init, and not even in create. But in onObject created, the sole purpose of this method is that this runs when all of the sibling components have been created. Their onObject created methods might not have been called, but at least they are there, and you can query them and get pointers to them if you need to. And so that's why we do the resolve pointers here. We leave the actor context uninitialized. We initialize the scheduler, and we update the scheduler. So this is called update, but it's still in the terminology of basis that would sort of be a tick, because update is typically called update. Like this update here is a variable time step update, and tick is a fixed step update. And we want the update of the action scheduler to actually be a tick, so maybe I should rename that to tick at some point, but it's called update for now. It's no biggie. On message received we can probably actually take away. Then I did some testing stuff here. So I created a dev action, which we'll get to in a bit. I also, to this component, I added a function called addDevAction, which just immediately, as we can see by this, it adds a dev action to the primary layer and then doesn't care about errors. This is something that I'm going to remove in just a little bit. The reason why I want it here is that we have this function is registered to the command prompt. That's a very long line, so let's split it onto several lines. So command prompt essentially allows us to register functions that we can run directly from the command prompt or the console or whatever we want to call it in the game. So in this case we can type ai.test, and that will run this function. This function is a global function. So in order to actually use that, we need to somehow just hook up the pointer to the actor component. So we store a global pointer here, and then we run the action. This means that we can actually, while this system is in effect, we can essentially only have one of these components ever, because it will override the pointer to that. And so here in create, we just set that. So this stuff is going to go away, but it can be useful just so that we can add this action there and see that it actually does what it's supposed to do. So what is the dev action then? The dev action is our first little action class or struct. I'm so stuck in my C++ mindset that I call these things classes, but they are of course not classes, they are structs. And the dev action, the only thing it actually does is it starts counting the time it has been active, and it stops itself when it has reached 4 seconds currently. Stop reason finished. And when it starts, it prints to the console, the debug console, starting dev action, and then when it stops, it prints stopping dev action. And the reason why it was stopped. All the other methods are simply just stubs. Well, the state returns the state, destroy destroys it, get type, like I mentioned previously, I might not actually need that, but it's there currently, and debug draw doesn't do anything yet. Update just updates the time and stops itself, and then returns the state. So pretty easy stuff. There was one kind of interesting thing here, which I needed to, and sort of like a chicken and egg problem here. If we go to action scheduler, this init function was previously used to initialize the memory that we allocate here. We start by allocating a pointer to an action of type T. This pointer is fully allocated in the sense that it reserves memory for it, but it's not initialized. We need to initialize it specifically or explicitly. And typically I do it like this, so I do ID reference the pointer, I assign something to it, and that thing would go away. Something like this. But the init function actually needs the pointer to the actual class, because we need to actually initialize the interface with the pointer to itself. So this stuff doesn't really work. So instead what I did was I now just pass, I don't return anything from this function, but I pass the type there. So essentially does the same thing, but rather than returning a fully initialized self here, it just gets the pointer to self, and then we just set it here. Fill in all of the members. And as per our requirements for the actions, they are required to actually take an actor context. This is the way that this action could then, for example, query the vehicle controller component, things like that. Now this dev action doesn't actually do anything interesting with the dev with vehicles, so it doesn't use it. It needs to be given here anyway. Right. And so since we get the pointer here, we can just pass it here to action pointer into the interface, and that way we get the interface initialized. Let's make sure this builds. It does build. Okay. So with a little bit of luck, if we now add one of these guys to our, well, we can actually perhaps create a completely new object type with this, just as a test. And the nice thing is that since this actor context doesn't require us to have this vehicle controller component, it just, if we have one, then it hooks it up. But if we don't have one, then it's not really a problem. We can just add essentially just this one component to a new type and try it out with that. So let's do that. Let's add a new type here. Where did my window go? I don't know. Restore. Hello. Where are you? Move. There we go. Went somewhere off screen. Off all my screens. That was weird. Okay, so we already have an AI blueprint here. We have a racetrack, AI racetrack component. This was something that I experimented with at some point. Never really went anywhere. Action test. Let's call it that. And we need this registration name, as always, when we want to to add a component, and as always, it's going to complain to us that we haven't actually registered this class here with the browser, but that's fine. Okay, so we only want the AI stuff to exist on the server, so remove it from the client, only run it on the server. And of course, since we have this global pointer here pointing to the component, it's even more important that we only run it in one place currently. Okay, right, and now we could perhaps do one more thing. We can add here to the list of objects that we want to be able to spawn. We can add our new, what did we call it? AI action test, I think it was. Like so. So now we should be able to quite simply go into a level and just spawn an action test, which will create one of these guys, which will register the function ai.test, and then we should be able to run it and see starting dev action and then stopping dev action 4 seconds later. If we succeed in all of that, then that's nice. That's very nice. Right, so now we can do something like AI dot, and it tells us here that unregistered namespace AI. There's nothing there. So let's spawn the action test. And now if we do the same, it will tell us, hey, there's a function in the AI dot namespace. So that's cool. Okay, now let's watch this space here while we run this. Like so, and oh, that didn't go well. Yeah, it actually crashed, even though it's not really supposed to crash. The reason it crashes currently for me is that while it is trying to get the call stack for a panic, it seems like the Zig standard library actually crashes. So that's kind of interesting, but it's very annoying because it means that it brings down the whole host application with it. I haven't really investigated why that is currently, but that is what happens. So let's run a debug build and try to see what's going on. I'm gonna pause here because I need to build this debug build, and it's gonna take a little while. Build the C++ code. So be back in a sec. All right, so I'm back, and we now have the build, the debug build built, and I think I have a hunch where this goes wrong. Let's see if we can maybe do something like that. We need to spawn in the object and run this, and see what we got. So switch on corrupt value. Yeah, okay. Yeah, I think I know what the problem is here. I think the problem is the fact that we have this state here. We switch on the state, right? And this looks like we are initializing it here. But since the thing here is that we do this weird dance with the self pointer that I talked about earlier. I think we need to do something like this for this assignment to actually be made. I think action state is not filled in, and action time is also not filled in, because we're only setting these two. So probably something like this, right? We fill in those, and that's supposed to be comma, and then we can just take that comment away. So we take the self pointer here, which is which is allocated but uninitialized. We dereference it and we assign this thing. We can still use the pointer here because it is pointing to the correct memory address. And I think this assignment, now that we are actually assigning it with self here, now we should get these assignments done for us as well. And if we don't, we can always, of course, do them there by hand. But I think this should fix it. This should fix the switching on the corrupt value. Let's put that back in there, and we can run the game, and we can try this out. Action test, spawn in the thing, and we run the thing. And yeah, now we get better behavior. Oh, so we're starting the dev action continuously. That's not good. That's not good. That's probably because we haven't actually set the state here to actually be started, right? So self.state is action state dot start. Nope. No, it's called active actually. It's not started. Active. Yeah. Now it should work. So now hopefully we should be able to start one of these tasks, these actions. Let's move that out of the way. I need to spawn it first. Spawn action test, AI test. We get starting dev action. 4 seconds later, we should get stopping dev action. And the reason is that it finished exactly how we imagined. Now, we can do another one. We can just call this again, and we get another starting dev action. And in a second, we will get the same message again. It finished. If we run this twice now, so one quickly after another. So start and start. You can see that we're stopping the action that was ongoing, and we get interrupted. And then we get starting a new dev action, and then it finished. So even with this, we can very quickly see that the concept of the queue is all there. It works, and we can. So essentially, what we did was this: run immediately. We clear the layer, and the layer looks through. A clear layer looks through the layer and see. And sees if there are any actions there, and it stops them with this interrupted reason. Destroys them and clears it. So that is why that happened. We sort of clear the whole thing and then immediately start running the new action. Okay, cool. This took a little while for me to figure out why this thing happened, but yeah, that makes sense. We need to initialize it like this, just like we're initializing anything. When you do that, then these assignments are brought in as well. So cool. Okay, now we have an action that we can run. We have a system that we can add more actions to relatively easily. And I think we can start to turn our attention to the driving pretty soon, and then we can wrap that driving behavior in an action. Or I shouldn't say behavior, because behaviors are a slightly higher level of system, I would say. A behavior typically consists of multiple actions, so you can, for example, chain them together, like we've seen with the queues. And we'll probably get to behaviors later on, but everything starts with actions, and we'll want to create our move to action as soon as we have the driving system in a reasonable state. So in the next video, I'll get starting on the driving system. We'll put a pin in this action scheduler and actor component system for now. This is a reasonable first version for that. And it should be really handy when we have the driving system in a better shape. So, I'm going to end this now. I hope to see you in the next video. Have a good one, and bye.